All right. So why don't we begin? My name is Joe Raczynski, as I mentioned earlier. I'm glad that everyone had a chance to join today. We may not take the full hour, but feel free, if you have questions, to please jump in, ask away. A few pieces. First, I want to introduce myself. So I am Joe, and I'm based in Washington, D.C. I work in the legal division, and my role is kind of unique. It's sort of bifurcated into two different halves. The first half is to make sure that all of our products and services in the legal group run and work well with our customers. So I'm customer facing. And that includes, I don't know, probably 100 to 150 different products and services across the board. The other piece is really consultation. So the second half is to listen to our customers, find out what's going on in the marketplace, and share that with other customers, but also to do more trends discussions. So I spend a significant amount of time talking with our customers, from the largest law firms to government agencies and once in a while to corporations, about what's going on in the market. So a lot of the emerging technology I spend most of my time on, which is inclusive of cybersecurity, artificial intelligence, the cognitive computing, virtual reality, mixed reality, the bots that you might start encountering a little bit more of, which are like the Amazon Echo, Google Home, those types of technologies. So we spend a good amount of time going up and down the East Coast in the U.S. working on that. But I've started to expand a little bit more beyond that to Europe. So I'll be in Europe, in London, not too distant future, talking about blockchain. So blockchain is one of those technologies, which is quite fascinating to say the least, and we'll jump into that in just a brief second here. The other piece that I wanted to let you know about is, and you probably are aware of this, but I'm not sure if everyone is across Thomson Reuters, and that is that this is a service that they call Pay It Forward. And what that means basically is that each and every one of us has the opportunity to speak with fellow colleagues across the organization about whatever it is that they work on, whatever they may specialize in. If they have a certain aptitude or interest in something, they can share that with the group. So that's all I did. I signed up for this for blockchain, as well as I have another talk tomorrow, 2 talks tomorrow, as I've had 2 today. But tomorrow is on cybersecurity. So if you have any interest in that, that's available as well. All right, so let us jump into this. And again, if you have any questions, it's free-flowing. It's a smaller group in the afternoon. For me, it's the afternoon here on the East Coast of the U.S., but jump in. So let me go forward with this and talk a little bit about what I think is going on right now in the big, and it'll lead into the blockchain discussion. So I personally think that this is an absolutely incredible time to be alive. I think we sometimes take for granted all the things that are happening around us, that are literally happening around us over the last few years and going forward, no question. It's what I call sort of we're living exponentially. There's all these different facets that are happening simultaneously that are having a major impact on our lives, both professionally and personally. It's this exponential growth of nearly everything. Everything that's happening around us. Think about robotics, drone technology. You know, we've seen what's going on hypothetically with Amazon and doing deliveries. There's going to be a company in the next few years that's going to have a drone that will guide you and your car to an open parking space in a large lot or garage. There are drones right now that are floating above certain parts of the world where there's large swaths of forest to prevent forest fires. So they'll have a little sensor at the bottom of the drone looking for hot spots or temperature changes that would indicate that there's a fire going on. These are the types of things that are happening. The autonomous cars, we're certainly well aware of what's going on with the cars that are being able to drive themselves, with what Google's doing, what Uber is doing. I mean, Uber's got that already working in Pittsburgh, Pennsylvania in the United States. There are several organizations that are doing this in certain parts of Asia as well. So the autonomous cars are another piece. In the biomedical world, we're talking about the production of organs, Very easily. I just was reading something prior to joining this talking about there's now been somebody who's joined a pig and some human cells to start developing organs for humans inside of a pig, potentially. And that just came out today. The old reference that I always make is the rat that's growing the human ear on its back. And it's actually living, growing tissue on the back of a rat, which is a frightening sight to see. But it shows you what's happening, and they're leveraging all of this different technology. The last piece of this that I wanted to talk about in terms of bringing relevance to it is the mobile devices. So it was 10 years ago almost to the day that Apple came out with the first iPhone. If you think about the iPhone and all the different aspects of that, or even the Android devices, every single piece of our life almost is in that. I mean, your scheduler, obviously your phone, your camera, your video camera, all of your music, your video. I mean, you can use it to find the level point of a wall if you're putting up a picture or a frame or something like that. I mean, there's a million uses for it. And it's all been collapsed into a tiny little device that we sort of take for granted at this stage. So what is going on? Why are all of these things happening right now? It's what I sort of call the trinity of forces. It's the triumvirate, trifecta of different things that are coming together right now that are having a significant and major impact on all of the pieces that I mentioned. So the first piece is that infinite memory. So way back when, in I believe 1955 or was it 65, IBM had a mainframe computer with 5 megabytes of RAM in it, and it was the size of maybe your bedroom. A large or relatively large room that housed this huge device that cost $150,000 back then, and it only had 5 megabytes it only held 5 megabytes of information. You flash forward to today, you can buy gigs and gigs of data or a device that will hold gigs and gigs very easily, very cheaply. I have this image that I sometimes show on a different presentation or talk on artificial intelligence, and it's the little chips that sometimes people put into their phones or they put into their cameras or whatever the case might be. It can hold now up to, I mean, gigs and gigs, like 64 gigs for $100. So that exponential growth has taken off for the memory. The second of the three is infinite processing power. And this is where we talk about Moore's Law. And Moore's Law is that old law that we've all probably heard of at this stage, which says processing power essentially doubles every 12 to 16 or 18 months. The way I like to best explain that is that the computer that we all could have bought or did buy in 2001 had the processing power of a gnat. It's a little bug. You fast forward to around 2015, and it had the processing power of a rat. So that $1,000 computer that you bought, maybe off of Amazon, would process at the speed of a rat. Now, you get to 2025, and you're talking about the capacity to process as fast as the human brain. Fast forward to not too much farther from where we are right now, let's say 2040, it's another 23 years or so, that $1,000 computer can process as fast as all of mankind. So that's the second piece. The third piece that sort of ties this all together, in my opinion, is the artificial intelligence, the algorithms. Now, this is where we're starting to see a little bit more of a leaning in for all of us in terms of that technology, being able to talk to Amazon Echo, being able to talk to Siri, talk to Google, OK Google, and hopefully that won't trigger anybody's devices right now. But all of those things are starting to come together. The algorithms that were originally created by humans and are starting to learn a little bit more. It's that machine learning. It's the ability for those programs to start to figure out how to best maneuver, how to come up with better solutions, faster solutions. And this is coming about much more quickly than people had thought. Elon Musk recently said, hey, with like AlphaGo, or this program that I think Google came up with to play this game, Go, which is much more complicated than chess, which it won against the best Go player in the world recently, that this stuff is growing so quickly they did not anticipate it. So this is all of that exponential growth that I'm talking about, that trinity of forces. So one of these things that is going to be leveraged is the blockchain. So we'll get into what the blockchain is right now. And let me jump into, I guess, a bit of an agenda piece just so we're all on the same page. Quick overview, and it's very simple. What is blockchain? I'll do a quick definition around that, and then we'll see how it unfolds over the time that we have together. A little bit of context. So the history, the present, and the future, I think, are important to realize in terms of understanding how blockchain works, and then what impact it'll have on all of us. Again, professionally, personally, it is going to seemingly enter all of our lives at many different angles. So I would love to show you this video, but in a prior time of going through this, it does not work well over WebEx. So if you're interested in seeing it, I've just put the video on YouTube under my own account, but if you're interested in it, I can send it to you after this. It might be worth seeing. It's a 4 or 5 minute encapsulation of what the potential is for blockchain. All right, to get to the definition. The way I like to describe it is that the blockchain essentially is a database. It's a spreadsheet. If you deal with Microsoft Excel at all, it's like having a spreadsheet that's massive, but that's distributed. So you're not the only owner of that spreadsheet. You might have, 10,000 people that all have access to that spreadsheet and all have a copy of it. So when there's a change to it, each and every one of those groups has to sort of approve it. And we'll get into that in a little bit. But it's really a vehicle for transferring value and holding records at its base level. So every block basically contains information about what you want to store on it, so what you're saving in that database, and then it has information that's linked back to the other blocks. So it's a continuation. It's a build out of all these blocks so that you have a database that's secure, that's safe, that's immutable, and we'll get into all of this a little bit later. And by immutable, I mean you can't change that data. So let's talk about the beginning of the internet and how it applies to this. Sort of an old story, but Paul Barron worked for a particular organization, and he said, you know what is kind of difficult in today's day and age with the advent of, unfortunately, nuclear weapons and, countries attacking each other, is that more often than not, all of those systems that a government would run or that an organization would run was centralized. So you'll have this big old server or several computers that have all the information just on those computers. Nowhere else do they exist. So if you look at this little picture in the middle, you see, wow, everything runs through that center dot. All the other random questions or queries that people might have all go back to the same computer. What would happen if that computer was destroyed or a virus got on that or something else happened to it? You would lose everything. So what he came up with was the origins of the internet, the idea that, hey, let's decentralize everything. Let's make sure that every one of these little nodes, so the dots, which are connected to each other, they all have a copy of what's going on. Each one of them knows what's happening. All the information is stored in a disparate way, so there's not necessarily one location that you would have that information. So it's distribution, of course. And that's really the center point behind the blockchain, is that it's not one entity that's verifying that something's happening, it's multiple. And we'll get into that with a better example in just a second. So again, we're talking about moving away from the central servers, attempt to move to more of a grouping or an ecosystem of interconnected computers that are talking to each other but are all sharing the same information. So surprisingly, and if you hadn't heard this before, all of this comes back. So blockchain has its foundation with Bitcoin. So Bitcoin, the cryptocurrency, the sort of hypothetical world currency that's out there right now, that started, I'd say 8 years ago. I think 2009 it came out. So the technology of Bitcoin, the underlying technology is blockchain. So it's rather fascinating that this bizarre little thing that popped up, which was created by, no one really knows who actually created it, and we'll get into that in a second, but it was an edict that came out in October of 2009. Basically, someone put out this white paper that said, hey, we want to take the power away from the government. We want to take the power away from the banks. We want to put that into the people's hands by giving them their own money so that they hold on to their own money. It's either going to be on their phone, it's going to be on their computer, it's going to be fully encrypted, so I can send money to Adam. So, Adam Blake is on the call, and I'd be like, all right, I want to send Adam some money, but I don't want to go through my bank. I don't want to go through Visa, because Visa might take something. I want to go through PayPal, because PayPal is going to take a certain percentage away from that. So I want to directly send him money. I can do that with a cryptocurrency like Bitcoin. So the idea here, going to the bulleted points, is that it's peer-to-peer. There's no central banking authority. Relies on cryptography. So it's highly encrypted. All of this is surprisingly pretty sophisticated and evolved to such a form that you should feel, or most people feel, very secure with this. And then we can get into sort of how that works and how it's connected to each other in terms of the computational race earned by Bitcoin. So who's behind the scenes sort of making sure that these things are happening. Well, maybe I'll just talk about that a little bit more real quickly here. So the idea of this decentralized view on the world is that there might be 4,000, 6,000 other computers that all have a copy of the registry of who has what with Bitcoin. It doesn't say who the person's name is, but each person that has Bitcoin has several different addresses. More often, let's just say they have one address. It's almost like an email address, but it's an elongated crypto key, and all that crypto key is a really long stretch of numbers and letters that are all strung together. It doesn't make any sense to you if you look at it. It's really long, but it's assigned to you. So if I wanted to send someone money, I would say, okay, I want to send $10 to Adam. I would send it through my phone. I would know his particular address. I can send it via email, or I could send it to him directly through that address that he shared with me. And at that point, it gets sent to him, but it takes some time. It's not immediate. It might take upwards of 10 minutes for it to be verified, or by verified, it means that it goes to 4,000 to 6,000 different computers around the world to verify that, yes, I, Joe, am sending Adam this $10 at this point in time. But they all have to agree that this is happening. That there's no shysters involved. There's no one trying to deceive another person. But then once that is verified, it's then put into the blockchain, so it's forever listed like a receipt in the ether on a computer that says, hey, this happened at this point in time. So people get paid. So if you were a miner, a Bitcoin miner, you're running software on some server that says, I'm going to verify this. My job, my computer's job, is to verify that Joe did send that money to Adam. And your computer is running all day long, is using a ton of electricity to try to solve all of these mathematical problems to verify that these things are actually happening. It's really kind of a foreign concept to think about, but it's working pretty darn well, and this is where the blockchain is using the same technology to verify that something is happening, and we'll get into more of those examples in a second. So why do we need to have this sort of thing? Well, if we move away from Visa or MasterCard or American Express, or if we move away from, surprisingly, if we move away from the banks, it's difficult to say, okay, well, we used to have one authority, let's say Visa, saying, yes, this happened. Joe went to the store. He bought a candy bar for $1 US. He bought it for $1. It happened. We'll take care of the transaction. Now we're talking about this is digital, and we're not. Let's say we're not going to trust, or we don't want to. We want to bypass Visa. The cash spend. So if I were to give that store $20 for that candy bar, it's a transaction that happens right there. I'm giving them $20 US. They're giving me the change. I'm getting the candy bar. That's clear. But in the digital world, it's not. I mean, we're sitting at our computers, we're on our phones, and we're making that transaction. We have no idea who's getting it, how it's working in the back end. So this is what's solving the problem. We can apply it to real estate deeds. We can apply it to the music industry in terms of who gets royalties for a song. And we'll talk a little bit more about that in a second. But the idea is that there's this verification of multiple groups have to verify that this is actually happening. So Bitcoin actually has a $12 billion market cap now, and I think it's up to like 8,000 different nodes around the world verifying that this is actually happening. You might say, well, what if one of the computers says, no, I don't think this actually happened? There's a sophisticated system that says, okay, this computer says no, but all these other computers say, yes, this is actually happening. So what goes on is that if one says, no, I don't believe this, it actually goes to the chain or the computer that says who has the longest chain of record. So all the different blocks that have built out, all the different receipts that have happened and are loaded into this, whoever has the longest chain rules the roost, so to speak, because it's basically saying that it's been verified for the longest period of time. So let's go back to them as the authority and say, yes, this is true. So it's very difficult to upend that. There was some survey that I read recently that said the computational power to upend this sort of system would be 2 or 3 times the power of what Google's engines and what they run daily for their own systems. So it would take a tremendous amount of power, computational power, to upend this ledger that exists, or any other ledger that might exist through other blockchain technology. So if I were to simplify it again, and I'll whip through this a little bit because it becomes a little redundant, but blockchain is a database. It's a ledger. It's publicly distributed, so that means it's not just one group or one government that's sort of running it. It's actually multiple entities that could run it. We'll get into these private blockchains. We'll get into public blockchains, so they'll give you a better understanding of how that works. And then the data is stored, as I sort of mentioned, by consensus. So everyone has to be in agreement that this transaction happened before it's actually recorded and saved into the block. So it's distributed, it's decentralized, it's immutable, which means that once it's up there, you cannot change it in theory. So in practice, I think there's been a few times on different blockchains where they've gone back and sort of retrofitted things when all of the groups get together and say, yes, by consensus, we believe that there should be a change to this, and then they might change it. But quite honestly, the true blockchains are immutable. You cannot change them. They're permissionless. The cryptography behind it is very important, and the network effect and the trustlessness is also important too. So looking at this, there's 2 things I want to sort of highlight. The first is altcoins. Bitcoin is an altcoin. There are approximately 200 different cryptocurrencies out there that are like Bitcoin. It's shocking. I don't even know if there's 200 currencies. Well, it's probably over 200, around 200 currencies around the world, period, just for nations. But there's 200 sort of Bitcoins out there right now. Most of them, quite honestly, from my vantage point, are sort of scams. People have said, hey, blockchain is amazing. Let me develop something where people can get in on it and come up with their own currency. And we can hopefully make some money off of this. There's coins called Dogcoin, Litecoin. There's something called Ether out there, which is based off of a platform called Ethereum. If you have not heard of Ethereum or Ether yet, that is one that I would absolutely keep my eye on. It's kind of like Bitcoin 2.0. Yes, they have a coin that you could buy if you want, but what they've done is they've developed this platform that allows people who code, for now, like hardcore coders, can come up with their own code and build it on top of the blockchain, which means you develop a system or an app that uses the blockchain to store the information. So all critical information is just stored there. And like I said, it's immutable. It's things you can make calls to. So I want to know more information about who owns a property. You can use this app that's built on Ethereum, and it reaches out to the blockchain, so the database, pulls that information back, and oh, here it is. I can trust it because all these other groups have verified that this transaction or this property exists. So Ethereum is a big one that's out there right now and making major waves. There's a lot of the banks are starting to test on that Ethereum platform. So what are they trying to do with it? They can build smart contracts. So a smart contract, because I come from the legal world, I work in the technology aspect of the legal world, I might have a small bent towards this during this discussion. But a smart contract is just a contract that you might have, like a legal contract, whether it's a will or something else, maybe even, of course, like a lease or buying a place, that has something built into it that does not need human intervention. I'll go into an example of this in a bit, which hopefully will be enlightening. But smart contracts are one thing that are being built out. Payment systems, like we sort of described, where Bitcoin or another coin that comes down the road that a bank might come up with will upend the system. So payment systems will definitely be used. There are toolkits out there, and I think a good toolkit would be Ethereum's platform. There are consortiums. So the top 80 banks right now have come together because they realized this is a major threat to their existence. And they've said, hey, let's get together and let's try to come up with something that will leverage this technology so that we won't be, sunset ourselves. So they're going to try to use some of this technology right now for their own good. There's other bank initiatives around it too. So there are, of course, different ecosystems. We've talked about the Bitcoin. Colored coins are fascinating. It's the idea of you leveraging the blockchain to create ownership of something, whether it's ownership of your house, your condo, an asset that you might have of your car. It's basically making claim to something by putting it into the public record, and they call them coins. They're like colored coins. There's more to be coming, this sort of evolving right now. That's one thing that's out there. Side chains, this is kind of a bizarre terminology, and I won't get too deep in it, but it's the idea that the purists think that the one and only true blockchain, and there are many of them now, but the one and only true blockchain is the Bitcoin blockchain because it's been around the longest. It's already been tested considerably by hackers trying to break in, trying to disrupt it. So it's really well built out. But a sidechain is built off of that ledger, that blockchain that Bitcoin uses, and says, okay, we'll use the same rules, same regulations, the same processes that Bitcoin is using, but we're going to do this for something totally different. We want to do it for land registry. We want to do it for ownership of cars so that our government knows who owns what, when, what the car is worth, for tax reasons. All of that can be put into this ledger, but we're going to leverage that side chain or that system. So anchored chains, which are somewhat similar. There's specialty chains. I'm not going to go into all of that. And there's, of course, as I mentioned, other cryptocurrencies. This is the part that I've always been kind of conflicted on. There are two visions on the blockchain. One is a public one. So Bitcoin's is public, the Ethereum, Ethers is public, and there's a ton of other ones out there, or a good number of other ones out there. Those are public. That means that I can come up with a product or a service. I can build on some of these things to use those blockchains to save that information as much as I want, and it's available to anybody. There are organizations that are coming out with private blockchains, and I sort of struggle with this. I get it, maybe in theory, but the idea of a blockchain to me is supposed to be open. Doesn't mean all the information is open and clear to everyone who can see it. It just means that the ledger is open but secured. The private one is almost like you create this private blockchain that maybe only a few groups have access to. To me, that's like, well, then what's the point of that? Because if you have one database that's sort of centralized, that defeats the whole purpose, it seems like. Then you might as well just have a database of running SQL or something behind the scenes that you're saving there directly. I don't see the redundancy that you would have with these public chains, but it's something that people go back and forth with. But just something to think about. So the first example of a smart contract that I want to tell you about is, and I thought it was a good one. I did not come up with this. It was a lawyer up in Philadelphia that came up with this. He uses the vending machine as a perfect example of how a smart contract using blockchain would work. So you have your vending machine, and we all probably have used these in the past. A lot of them are smarter than others now because you can use your phone or whatever to use payment. But at its base level, you go to this big old refrigerator-looking thing, and you want to get some Doritos out of it. The machine just sits there. It knows only a few different things. It knows, okay, you've decided to put money in. So it's okay, now I need to start working. This person's given me money. My next thing is to listen and find out what it is that they want. So you punch in what you want. You want the Doritos bag that's in the upper left-hand corner. You get that, and it drops down, and you were able to pull it out. So it's self-executing. It's very straightforward. It's self-identifying. It knows that you've given it money. It now knows the directions that you've given it, which means you want that bag of Doritos. It's immutable. Once you've made that choice to hit A1, the top level, the first item, it drops down. You can't change it. You got your Doritos bag, and that's it. I mean, you could try to shake it, but well, what's the point? It reduces the human factor, and I'll pause here for a second. So the positive and maybe the negative of all of these things I've talked about, even in the very beginning when I was talking about the robotics, the autonomous cars, the biomedical, the mobile devices, things like that. The positive is that it's going to make, hopefully, our lives a lot easier. The negative is that it will have an impact on jobs, maybe in the short term, over the 5 to 10 years, being short term, where people will lose jobs in various industries, the banking industry, in real estate, in so finance. I mean, there's definitely areas that are going to be hit. If you ever have to go to a notary republic, somebody that basically says, hey, you have this document that you need signed. That individual you go to at a bank or you go somewhere, and they're verifying that you're actually signing that. They have like a seal that they press into the paper, and they document it into their book. That is one industry that will go away. Those individuals over the course of the next 3 to 4 years will probably not have that sort of thing that they'll be doing anymore because the blockchain will sort of take over that sort of role. So blockchain is going to have an impact on people's jobs. I think the positive thing about this is that the more that each and every one of us knows about this, especially in every one of our industries, and you all come from a vast number of different groups and industries, if you can leverage this knowledge, this understanding, and start delving into it a little bit more, you can certainly help the organization or yourself benefit by pushing things forward and coming up with new ideas that could be a whole new industry in and of itself, a new application, a new process that you could actually develop yourself. So a little side note. Going back to this piece, so breach, you're not going to break into this. The thing you probably bought was $1 US. Is it really worth breaking into the glass or something like that? Probably not. So it reduces that human factor and creates sort of an embedded contract with all of this. There's multiple steps and multiple parties that are a part of this as well. So there's no central piece to this. Now, this is a little bit of gobbledygook for some who don't program, and it's still gobbledygook to me, and I program a little bit. I sort of came up with this and started fiddling around with it, I don't know, 6 months ago or so. What this is a little bit of code that would be built on that Ethereum platform. Now, what does it really say? Let's say you have a will that you've created. You have some kids, and you go to your attorney, and your attorney draws up the will just like they would at any other time. It's probably a really thick document that has all the information about your assets, how you want your money distributed, things like that. So they take that will and they can codify it. So they can put it into a machine that hasn't been developed yet, but in theory, you'll put it into a machine that says, okay, let's look for trigger points within this will so that we know what to do with it without human intervention. So in my bizarre example, and I apologize in advance, this is how it would work. The will is going to be very simple. The parents have 2 kids. Upon the parents' death, if the 2 kids are not married, they do not get anything of the estate. So if one is married and one is not, that individual that's married gets the entirety of the estate, all of the money, all the assets goes to them, and then the money is sent to them. So in this really small version of a will, it's codified, and this is how it turns out. So back to the screen here. So what happens is it's put into this machine, and basically it says, let's go check with our local state government or wherever you are in the world. There's certainly death records that are put into place. So unfortunately, the parents die. Every day, this system goes out and makes an API call, basically saying, hey, let's go check with the local state-run government and see if these people are alive. Oh, unfortunately, they passed away. So the second thing it does is that it then goes to other state governments or whatever the case might be, even our public records that we have at Thomson Reuters, and says, okay, let's check to see if those 2 individuals are married. So we want to check to see if the kids are married. It says, okay, well, what we found is that kid B is married. Kid A looks like they're not married and the parents have passed away. Uh-oh, for kid B. So kid A essentially gets 100% of the estate. And let's say it's liquefied already. So automatically to a bank account, all of that money goes to kid A because they were married and because it was stated in the will. Now, all of that, after it was written up and agreed to by the parents and the attorney, it was signed, we put into the system, and this would all be done automatically. So the attorney didn't have to do any of those checks. The attorney didn't have to send any money to anybody. That was all done automatically. And it was done through a smart contract, which leverages blockchain. Kind of neat, kind of scary, all at the same time. So where are we headed? Here's another example. So way back when, I think when I first started getting music, I would get CDs. So I'd go and buy my CD or whatever the case was. So you'd go to the record store or order it online, you get your CD, the money would be given to them at that point in time, and then the money would be distributed. Now, it's actually far more complicated, and probably okay that it is this complicated, but what you're looking at on the screen right now is the royalty payment system ecosystem for music. So the person that comes up with a song basically gets a certain portion of that music, of that money, but then there's a ton of other groups that sort of share in that. It's the distributor, it's the person that put the music together, that published it, that advertises for it. All of these different pieces people get a share of, and it is mind-bogglingly difficult to figure out who gets paid when and how much. So with the blockchain, all of that could be automated. You would say, okay, the distributor gets 3% of this when a person buys it online through like Apple or through Music, through Google Music. At the point of execution, boom, let's automate this. Let's put it in the blockchain. certain percentages go to this group, to this group, to this group, and it's all spread out evenly, whatever was agreed to via the contract. But this is also changing a little bit. So I think one artist over the last 6 months said, you know what, I'm going to bypass all of that. I already have a solid group of fans. I'm going to go to my website and I'm going to say, hey, I am the owner of this. I've actually produced it. You can actually produce it themselves now with all the technology that's out there. So they have their music on their MP3s. And they then use the blockchain to sell it themselves. And they say, okay, if somebody wants to own this song for a month, they can own it for a month. And it'll actually pull the rights to that song after the month. Let's say somebody wants to just take a snippet, a 10-second piece of that song. That author has the control now to say, okay, I will sell the piece of that song because they want to sample it into other music that individual wants to create. It allows them that flexibility and get paid for it. And to record that into the blockchain, all of that is available right now and starting to happen. And that's going to deleverage and upset the record companies, the producers. All of this is fundamentally going to change a ton of different industries. Really kind of fascinating. Okay, so what and who are the companies that are involved in this? You may or may not have heard of some of these before. Of course, certainly you have Microsoft. So Microsoft's getting involved in it. Hyperledger is a consortium of groups. They're getting together, trying to come up with rules and policies around blockchain and how best to execute on these things. There's a counterparty. There's Ethereum's in the middle. It's a little bit difficult to see. I'm sorry for that. But understand there's a lot of groups out there. I'll pause for a second and touch a little bit on Thomson Reuters, even though I'm not really the spokesperson for them and what they're doing right now on that piece. I'll give you a little bit of insight in terms of my work or my understanding of what they're doing. Based on some of my discussions that I've talked with people, I believe their first, so Thomson Reuters' first entry into blockchain was October, not of last year, of the year before. So 2015, in October, they said, hey, this is something that's actually growing. We really need to look into this. This could have an impact on our business, could have an impact on our customers, and it could be in risk, could be in tax and accounting, could be in legal. All of them will have an impact. So they started playing around with things. I think what they did initially was build a system that would sort of mimic what would happen with a stock trade, so that if you wanted to go in, let's say you wanted to buy Amazon stock, you'd go in there and say, hey, I want to buy it at this rate. So you want to buy it at, I think it's like, what is it right now? Like $850 or something like that for a share of Amazon. It would register it. It would say, oh, here's party A to buy it, here's party B to sell it. It would match them together. It would record it into the blockchain, and it's immutable. So this happened on this date, this time, and this is how many shares were sold and bought. So they started playing around with that. Now they're moving into other directions, and there are things that are happening internally that I think are more tight to the vest, so they're not talking about it. Another thing that I had heard about, I don't know if they've moved too far on it, is this idea of land ownership. So there are, believe it or not, countries around the world that some people don't have a lot of faith in terms of their own governments. So let's say you have a family and you all have been on your plot of land for over 100 years, generations living on that plot of land. You don't really have a deed for it because you've been there, you've been on that property for a long time. You just know that, I've been on this land, I have my house here, and my property runs down to a line of trees that are half a kilometer away or something like that. So if you go to some countries, they might say, yeah, you own that. And you're like, okay, great, thanks. And then all of a sudden, they turn around the next day and like, actually, you don't. And so it's that one entity saying yes or no that you own that. Now, there's a country in Latin America, so Central America, that has tested land ownership using the blockchain. So it's not one entity saying it, but obviously multiple entities that all verify that you own this. So it wouldn't be the government coming in saying, okay, you don't own it anymore. You're like, oh, look, it's in the blockchain. This is what a ton of parties agreed to. So it's far more verifiable, in my opinion. So you're going to start to see that seep into state, local, and federal governments around the world. There's a lot of other groups that are sort of testing it. This is the year where companies and governments are starting to truly test and pilot these things. Last year was sort of the scuttlebutt, was just the discussion around it, but there's a lot of change with that. So about 15 minutes left. Let me try to get through a few other things here real quickly, see if there's any questions. Again, you can ask me questions along the way. Real world theory. So the way I like to describe this is, if you're in a business and you have rules or regulations or laws or systematic code that goes into whatever you're doing, it's blockchainable. In other words, it can be put into the blockchain and it can make and create efficiencies that are not there right now, which again will have an impact on everything. So right now, the forerunners in this are the financial derivatives, so options that people buy, the swaps, the futures, the forwards, just like variations on buying stock in a company, essentially. Escrow for physical or virtual property, data licensing and access to that information, like what we were talking about with the licensing for a song, employment contracts. All of that can be touched upon this. So some real-world applications that are happening right now. Delaware, one of the smaller states in the U.S., is the largest holder of corporate records for the U.S. So I don't know what the number is, but I feel like the vast majority of corporations in the U.S. are registered in this one state of Delaware, probably for tax reasons. So what the state is doing is they're saying, okay, well, we have all these records. We actually want to put all of that into the blockchain so that it is more secure, it is safer, and so they're moving in that direction. It's very powerful, and actually a real hat tip to the technology, and this happened, I think, in September of last year. Factum is a company that did what I was just telling you about, real estate transactions in Honduras. I heard recently it didn't work that well, so I know it's evolving. There's no question it's evolving. The boardroom, so boardroom decisions. So large corporations are starting to use blockchain to register decisions that the board has made, or if you own stock and you get these voter things where every once in a while they want to vote on what the shareholders want from the organization, whether it's new personnel in the office or direction that the company should go in, they'll start using blockchain to help secure that information. As I mentioned before, notary services are at risk. Healthcare is certainly going to be touched on. And then the positive there is the encryption level. Most healthcare providers, organizations battle this all the time. I'm not going to say across the board that it's insecure, but they have lots of issues with that. So this should make it more secure. Here's one that I'll talk about because I think it's kind of fascinating. A company called Slockit is based in Europe, and what they are trying to do is upend Airbnb. So Airbnb is right now upending and disrupting a lot of the hotel industry. Believe it or not, they really are having a significant impact on that because people are using Airbnb and those services much more than ever before. So Slockit came up with this idea. They said, all right, we're going to use the Internet of Things, so a device that's connected to the Internet, and we're going to leverage the Ethereum platform, so have a blockchain that allows somebody to program some language on top of it so that they can store information. So what they did was they came up with a lock that you put on your front door. So if you have Airbnb or you use Airbnb, you go to this website. Let's say you have a place that you want to rent out to people. You go to the website, you advertise, you have your pictures, you have, oh, it's close to this metro station, and it's very convenient to the stores, restaurants, blah, blah, blah. So the website's there. You decide to rent from this individual. You click rent. You buy the whatever. You spend your dollars or your euros or your Bitcoin or your Ethereum on that, and you show up. And you show up, and there's a doorknob, of course, that's electronic. It's connected to the internet, and you punch in your code because you're given a code that says, hey, this is how you get into the place. In that lock, it has the contract for how long you're supposed to be there for, when you're able to check in, when you're supposed to check out. It has how much money you've spent on it. It has your access, of course, the code for you to be able to get in and out. And it's recording all of this on the blockchain. So it's all secured. It's all taken care of. So this Slockit company has, I think, 2 people that run it. So the website's all self-done. It's automated. You upload your own information. Other people look at it. They click on what they want to click on, and they go. The other difference here between this Slockit and an Airbnb, Airbnb, while I've not rented out my place, apparently charges anywhere from 9% of the money that you charge to 15%. With this Slockit blockchain-enabled technology, they will charge 1 to 2%. So you're going to see that people would probably tend towards that once they feel more comfortable with it, once it evolves a little bit more. So what they did was they used the programming languages they had with their programmers on top of that blockchain Ethereum platform, and they were able to come up with this solution. There's going to be a lot more of those types of things coming out. BitTunes is just another version that we were sort of talking about. Money exchange. So if you ever had to send money overseas to different countries and you get hit by these large fees, that will also go away. I mean, it's going to shrink, like the what is it, Transwestern, or what is it, TransUnion? I don't know. I forget the name of it right now. But when you're sending money overseas, they usually take a large percentage of that money out. Even the exchange rates for like Visa, if you're traveling overseas from one country to the next, they take a decent percentage out of that. It can be upwards of 6 to 7 to 8% sometimes, adding all the fees together, ATM fees, things like that, and all of that could go away as well. So the money exchange. So there is a lot going on. The NASDAQ, which is an exchange in the U.S. for predominantly technology companies, is starting to look at using blockchain to record the transactions of the purchasers and the sellers of stock. Quickly going to some other things, here are some other real-world use cases or industries. You may recognize an industry that you're involved with personally, professionally, but it's pretty much everything. Real estate, healthcare, supply chain management. That's going to be a big one. Just the management of how much inventory a company has is going to be huge with that. Identity management is also huge. I mean, I could spend a lot of time on this as well in terms of at some point soon, we will all own our own identity in the blockchain so that you will have control over who gets access to your information and how much information you want to release, so that it could upend the Facebooks, the Googles of the world in the sense of their advertising. Because right now they're trying to gather as much information on you as possible so they can create a profile on you. Now, if you were to block all of that and say, hey, I want to share information with whatever companies I like the most, you could, and you would get paid for that using blockchain technology. Powerful stuff. That's all coming. So, in the last few minutes here, challenges. There are skeptics, and I'm sure there might be 1 or 2 of them on the phone right now, which I don't blame you. I was a skeptic for a long time. I had the good fortune of getting involved with Bitcoin in 2011, doing some mining, doing some trading on it way back when, and appreciate it. I wasn't sure where it was going to go or how it was going to evolve. I actually thought it might go down and disappear, but it doesn't seem like that's the case. So Bitcoin, for one, is something that is now being equated with like a gold standard, like a commodity of sorts. So other challenges, ideological motives. All of this has at its base anti-establishment roots. So the idea of the blockchain is that you're decentralizing things. You're taking the power away from the governments, from the banks, from everyone. So that's another thing that sometimes sort of is tough to wrap our heads around, but is something that's possible. The other aspect is the regulatory. There's privacy issues, sharing of information. There's fragmentation in the market because there's a lot of different groups that are trying to emerge as the power horse among this. Scalability is there, but there's some issues with that. And then the constant need for standards. That's why you see all these consortiums popping up. And there's the technology-driven solution. So all of that is one of the challenges. Now, second to last graphic that I have right here it talks about our past, our history. The internet was sort of the beginning of a lot of things. From that, if you go back, if you're old enough, email was like the first real true thing within the internet. I remember as a little kid, I would mess around with email. I was like, wow, this is kind of neat. I can send something to someone that I normally would have written a letter to. Then the web came out in like 93, 94, shortly after, and we're like, wow, there's images on this and there's some text on it. It was kind of neat. Then fast forward to smartphones, and what you've been able to do with smartphones are the apps, and the apps have taken it to a whole nother level. And if you look at Uber, Uber has just a ton of information. There's a sales component, there's a credit card component, there's an awareness piece of it, so it's GPS based. It's AI infused, like one of the things we were talking about earlier. So that's sort of the internet. Now, several people, and I would almost include myself in this, think that blockchain is another internet. It's another groundbreaking, important aspect of where we're going with technology. So it is the base level platform that will have an impact on all of us in all of our industries in the not too distant future. What comes from that, we don't know yet. We can start seeing as some of the things that I sort of outlined are the beginnings of it, but we don't know. We'll see what goes on with that. The last thing, I've written a little bit about this. As you can see, I've written on our internal, the hub site. I have my own site. I have some legal focused sites that Thomson Reuters has that have some articles that I've published on it. If you're interested, I'm happy to share that with you. Also happy to talk offline about any of this with you as well. But that is it. So if anybody has any questions, I'm happy to answer those now, or if you just want to send them, my last call I did this morning, which was the same coverage here, people sent me emails and had questions about things. So either or, I'm fine with. I'll open the call to everyone right now if you have any questions. I think somebody sent something. Oh, well, yeah. Someone clarified when I had a little brain snag there. It was Western Union rather than Transwestern or whatever I was saying. I don't know. So it's been a long day. I apologize. End of my day here. All right. Well, if there's no questions, I appreciate your time. Hopefully this was beneficial. It's exciting stuff, and I hope you probably hear that in my voice. Maybe a little too excited, but I appreciate the time, and if you have any questions, again, let me know. I'm happy to help.
Thank you.
All right, thank you all. Take care. Bye-bye.